Let me walk you through all of the different parts of Microsoft Azure and show you how they can help you create solutions and grow your business. It can be a little challenging to think about Microsoft Azure at first. If you're new to cloud computing, you're probably filled with questions and concerns about a wide range of topics, including how data is managed, security, and the process of developing and managing solutions. When it comes to the cloud, Microsoft Azure's cloud offerings and how you can use these pieces and services to build your solutions and to help maintain your business is the goal of this course. Using compute and data storage in someone else's data center eliminates the need for you to manage hardware and allows you to rapidly scale your data storage, computation power, and any other scalability you require without having to invest capital in hardware, according to Gartner's definition of cloud computing. In a cloud, resources and services can be provided in a variety of ways, depending on what we mean when we say cloud. IaaS, or infrastructure as a service, is one such alternative. This is where you get the bare bones of what you need to build your own computer system. Think about virtual machines, hard drive storage, networking, and IP addresses, among other things. A similar setup to what you might have built in your own data centers or with a hosting provider is possible. Platform as a service is another option. Here, the goal is to decouple your solutions from the underlying infrastructure and provide you with a platform on which to run them. You don't have to worry about maintaining your own virtual machines, hardware, or other IT infrastructure when using platform as a service. Components of an application platform such as web applications, databases, and other services are under your control. Another option is SaaS, or software that is delivered as a service. You're paying for or subscribing to an application or a piece of software at this level of abstraction. Gmail and Microsoft's Office 365's Exchange are the most common examples of this type of service. Alternatively, you may be able to purchase a service that is integrated into a larger solution. Sending text messages and receiving replies from others, as well as managing email campaigns, are all possible uses for such a service. There are a variety of reasons why people opt for the cloud. For example, you save time and money by only purchasing what you need to build a solution. It's a cinch to do. To get the platform or infrastructure you need up and running, it can take minutes or even seconds. This is a much more cost-effective option than purchasing and installing hardware in your data center, as you only pay for the resources that are actually used. Additionally, you'll be able to scale and deploy your system more easily. Different models for deploying application code will be discussed, and they all have different trade-offs in terms of how the application is scaled and what options you have, as well as in terms of how you package and deploy your applications. So there is a wide range of options, and one of them is almost certainly going to work for you. In a cloud computing environment, you only pay for what you use, as previously stated. You don't have to buy hardware and software in advance, instead, you pay for what you use. Adding more storage space means paying a little more. There is no overnight processing. As a result, you won't be billed because the data center has no need for your services. With a cloud-based solution, the overall total cost of ownership is lower. Last but not least, cloud computing provides new options that would be impossible to implement in a private or in-house environment. It's difficult to create a large-scale environment because of the sheer amount of money and time it takes. It's not just that cloud-based solutions can be updated and interacted with more quickly, but they also have the ability to take advantage of all of the other services offered by the cloud provider as foundational components. When discussing Microsoft Azure and the cloud, keep in mind that you have already made a significant investment in your own data center and in your own software. If you don't want to completely reinvest in the cloud, there is good news. You can, however, connect these two environments as you build cloud solutions, move data center solutions to the cloud, or build hybrid solutions. As a result, you should expect to continue using applications that run solely in your data center as you move forward. In some cases, your Azure cloud-based applications are either new or have been moved from your data center to use the cloud platform. Hybrid solutions are also common, in which part of the application can benefit from a cloud infrastructure and is therefore deployed to Azure, but connections back to your data center are maintained so that you can access the application code, logic, and data you have already invested time, effort, and money into developing. It is Microsoft's cloud, Azure, that we are going to focus on in this course. We will focus primarily on infrastructure as a service and platform as a service in this discussion. So, we will examine how to run your application code, whether it's in a virtual machine, a container, a web application, or some other serverless approach. We're going to look at data storage and processing, including the various formats and services available for storing data and the various methods available for processing that data. For example, we will discuss how to integrate Microsoft Azure services with your own data center or with those of your partners and organizations in other clouds, for example, in this session. We will look at networking to help you better understand how to connect your cloud and data center solutions and how to make use of networking technologies like content delivery, traffic managers, firewalls, and so on in order to better network your services. We're going to talk about management, which is critical if you're going to manage all of these different products and services. In what ways are they tracked? How do you put your solutions into practice? How do you control who has access to what? We will also discuss identity, which is critical in determining who has the authority to do what. At the management and application levels, we will see how you can use identity and other security options, such as storing secrets, to protect yourself. You can build with Azure, like many other cloud providers, by using a variety of services and offerings. So, how exactly do you put all of that together? Is there a way to put these pieces together to create a solution? The second is, what kind of building blocks do you have? There are so many services available in Microsoft's Azure cloud that it can be difficult to keep track of all the options. They used to play with building blocks as a child. And I used to lend a hand to these people when they needed it. Then again, I had just as much fun as they did. There were two distinct styles of construction as well. This is also evident in software development. There are times when you need a blueprint that lays out step by step how to create the solution you seek. Then how about a web app with a relational backend to back it up? This is how you do it. Then there are those times when you have a new solution in mind and you want to know what all the pieces are that I have and how I can put them together in order to create my own solution. You can count on me to do the same in Microsoft Azure, as there are numerous components with minor differences that need to be understood in order to get the most out of the service. Many services are available on Microsoft Azure, as you'll see when you explore it. And it can be difficult to comprehend how they all fit together. Microsoft is now attempting to categorize and organize these for you on their website. As a result, I will be focusing on a small subset of the many services available to you in order to give you a better understanding of the various capabilities you can use to build your solution, regardless of your approach. Do you need a plan? You'll see that there are some detailed instructions for constructing these contraptions online. In addition, if you just want to know what the services are and put them together in your own unique way, you can do that as well. For this reason, we are going to group these together throughout the course and discuss them as a whole. It's time to jump right in and help you get a better grasp on the Azure Cloud platform after all that. Kubernetes, the most widely used container orchestrator, is now fully supported by Azure as a mechanism for packaging and deploying applications. Using the Azure Kubernetes service, you can quickly and easily set up a Kubernetes cluster that can grow and change as you need. Azure also has a concept of container instances that can be used. A container has already been defined, and you want to run one instance of it. Provisioning an entire cluster or infrastructure for this isn't an option. To do this, all you need to do is run the instance for a set amount of time. To scale your Kubernetes service, you can either use this as a standalone instance or in conjunction with the Azure Kubernetes service via virtual hosts, which are essentially virtual nodes that can be added from the container instances nodes. Azure Container Registry is a natural fit for all of these containers and container definitions. Your container definitions will be cataloged here so that your container instances or your Kubernetes service can use them to run or host those containers in their environments. The management and execution of these containers can be accomplished using a wide range of standard tools and frameworks available within the Azure ecosystem. It is the idea of having code that applications run without having to manage virtual machines or even think about instances of, for example, a web application. You can write code in the form of a function in a variety of languages, including C#, JavaScript, and even PowerShell, and have it run on demand, usually triggered by some external stimulus, with Azure Functions, one offering in this serverless space. An HTTP request, a message, or some other event could be the cause. Logic apps are also available, which run without the need for a specific server instance and provide workflow and orchestration of various integrations between systems. Event Grid. This includes a robust mechanism for publishing and subscribing events that may occur in your applications or even in your infrastructure, allowing you to respond to things like virtual machines being started or stopped or to application events that occur. In addition, Logic apps and Azure Functions let you write code without having to worry about how the platform infrastructure is set up. As a result, managing the underlying platform can be made a lot easier with the serverless model. There will be some things that don't fit neatly into those buckets. Azure Container instances can be used as virtual nodes for the Azure Kubernetes service, as I mentioned earlier. As long as a specific event or trigger occurs, they can be used in the serverless model. Container instances are instantiated, run for a brief period, and then destroyed. Using container technology, you can avoid having to deal with infrastructure concerns. Like Microsoft's Azure Service Fabric, this is an option for connecting multiple services in an orchestrated environment. Containers could be those services. They could be anything from a simple executable to a web application or web API. When it comes to Service Fabric, it doesn't really care about the different pieces and lets you mix and match not only containers, executables, and web apps, but you can mix Linux and Windows containers and images as well. Serverless and containers and Service Fabric allow us to manage these cloud-optimized solutions as well as more traditional ones like a web app or a virtual machine. If we are talking about computing in the cloud, we can't avoid mentioning large-scale computation. In this case, I'm referring to the Azure Batch service, which makes it possible to manage the scheduling of jobs on a mass scale. So, if you have a lot of work to do, you may need hundreds or even thousands of copies of a virtual machine or an executable running in parallel. Using Azure Batch, you can set up a system to handle your large burst workloads. HD Insight will also be mentioned. These Azure tools are based on the open source Hadoop frameworks, but they offer a wide range of processing capabilities related to big data and computation. Then you might want to look into Batch and HD Insight if virtual machines and containers don't sound like they'll work for your needs because of the massive scale or parallel processing you need. See if they're better matches for you. We will show you a few examples of how you can use this compute in Azure to get you started. It's also possible to migrate VMs from Hyper-V or VMware to Azure using a simple VM migration tool, such as Microsoft's VM migration tool. You can do some research and use some tools to determine whether or not this is a wise decision for you. It's possible that it has nothing to do with money. Scale sets, availability sets, and managed disks can all be used to their full potential in this scenario. However, you are free to take this action. For those who have tens of thousands of virtual machines in their data center, there's an Azure migration tool that can analyze those virtual machines and provide the necessary path and tools to migrate those virtual machines to Azure. If you're looking for a solution for migrating virtual machines from one location to another, this tool can help you with that as well. That migration project is a good place to start if you're considering moving virtual machines and applications to Azure. Alternatively, you could use a Kubernetes cluster as an example. If you have 3 web application nodes, for example, there are a few API nodes in your system. A single cache server node may be possible. Using Kubernetes, you can manage and deploy this in a cluster using container technology as well. All Kubernetes command line tools are available to you. Docker clients can be used to do local development of your YAML file and then deploy or bring up an entire Kubernetes cluster in Azure using the Azure Kubernetes service. This is a working web application. To conclude, you may desire a globally accessible, scalable web application that can be accessed from various geographical locations. It's possible to have 2 instances of your web application and a Cosmos DB database in a single region, for example in North America. Using the Cosmos DB database, data can be migrated, transferred, or synced between multiple regions in a very fast and transparent manner because of its ability to perform geo-replication. Your web applications and Cosmos DB database will be replicated in a geo-redundant setup in another region, like Europe, Australia, or India. It's important to keep in mind that there are a lot of supporting services, such as networking, database, and storage, that you can use in addition to the compute options in Azure. Those are just a few examples. So we investigated a variety of Azure compute options. There are many modern options to choose from, ranging from well-known ones like web applications and virtual machines to less familiar ones like containers, the service fabric, and serverless architectures. All of these solutions are cloud-based. There are a variety of ways to configure them, but they all give you the ability to start your application and identify the different scale characteristics and manage to those. They are all built to be scalable and meet demand. Microsoft's Azure Cloud isn't just about Microsoft technologies, though. If necessary, VMware virtual machines will be available to you. With JavaScript and Java applications, as well as PHP, you'll be able to use it. For any type of application you're developing, you'll be able to deploy it and manage it in a variety of compute options in the Azure Cloud. We're going to talk about data in this module because it's critical to all applications, and the cloud is no exception. Cloud computing allows us to take advantage of all the hardware and scale in these data centers. So let's take a look at some of the most important aspects of cloud storage. For different types of data and different use cases, Azure provides a wide range of data storage options. I will demonstrate this to you. We will then move on to data processing. When we talk about moving data around, we are talking about ingesting it into your database and storing it permanently. When it comes to preparing for analytics, which we will discuss in the next module, we will need a system that can accept and store data in a format that can be used by various analytics tools. There are a number of characteristics that come to mind when we talk about databases in the cloud. They have to be able to grow. We talk a lot about cloud scalability, which means being able to deal with spikes in traffic, large amounts of data, and a lot of database interactions. They must be accessible. Our data must be backed up in a secure location that is accessible 24 hours a day, 7 days a week. Moreover, they must be universal. As a result, we can store our data in the most convenient location for our users or in a location that complies with our compliance and regulations, thanks to the cloud's global data centers. All of the options we will discuss here are capable of meeting these criteria. In order to ensure high availability, Azure's data storage solutions are designed to scale. Our applications have many options for global scale now that there are so many data centers available. Additionally, cloud-based databases or data storage can be self-managed, which is a factor to consider. This is most likely what you're used to hearing or reading. Virtual machines or containers that run a database software service can be provisioned in the cloud and managed by us. Cassandra, MongoDB, or a relational database could be used. Predefined images are available in the Azure Marketplace so that you don't have to build your own container or virtual machine from scratch. It's all set and waiting for you to use it. I call this self-managed because you'll be responsible for managing the compute, whether that's a virtual machine or a container, as well as the disks and other components that come with it. The data centers and infrastructure are being used by you to build and manage your own instances. As a result, you'll have to take care of patching any containers or virtual machines that you create. However, service-based data storage in the cloud is where we can get the most bang for our buck. An instance can be provisioned here. If we want an instance of something like a relational database, we don't want a machine or container. The scale characteristics are still up to us. Why do we need this to be so fast? What kind of burden do we expect to carry? Exactly how much data will we be storing in this case? However, this has the advantage of being managed by Azure. As a result, there is no need for patching. Managing the infrastructure isn't necessary in this case. Your primary concern is the safekeeping of your data and ensuring that the data service you choose will meet your requirements. Additionally, you don't have to worry about patching because it will be done automatically for you, and you can take advantage of the most up-to-date and secure backup environment without having to manage it yourself. Relational databases are now available in Azure. These are the databases that most people are likely to be familiar with as well. As a result, we now have access to Azure SQL. If you will, this is SQL Server in the cloud. However, there are a wide range of options to choose from across the entire spectrum of possibilities. A managed instance makes it simple to switch from on-premises SQL Server to the cloud. Using elastic pools or software as a service allows you to share resources across a diverse set of databases, even if their usage patterns are very different. So, it's very well suited to a variety of cloud environments. Other relational databases, such as MySQL, MariaDB, and PostgreSQL, are also available. The self-host or service-based model is available for all of these options. Virtual machines and containers can be used to run any of these, but they all have a service-based model that allows you to provision an instance of this so that you can focus on your application development or data storage. As a final point, all of these are built for the cloud, which means they are scalable, available, and global. It's not just relational data that you can use to build applications, there are a number of other options available. Your table storage is a critical component of your system. In order to identify a collection of data, you need a set of unique keys and corresponding properties or values. If you need to store large objects, such as files, we have blob storage available. You could also use blob storage to store files like PDFs, images, and other documents as virtual hard drives that can be accessed via the web, with features like caching and metadata that can be stored around those files. Azure queues are available for storing messages that need to be passed between nodes in your application for a short period of time. That in-memory storage can also benefit from the Redis cache and other caching options, which can reduce storage costs and improve performance in some cases. A virtual machine can be used to host a MongoDB document database, as I mentioned when discussing the self-hosted options. You can use Cassandra or Neo4j for a graph database, for example. As a self-hosted service, you have access to a wide range of data storage options, from documents to graphs and columns. This is because Microsoft's Azure Cosmos DB contains everything you might be looking for in a service-based environment such as MongoDB, Cassandra, or Neo4j. This is a one-of-a-kind database in that it allows for the storage of multiple model types. In other words, you can specify whether or not your Azure Cosmos DB database is a Graph 1 when you create it. In addition, the Gremlin API can be used to perform operations on the graph database. Alternatively, you can store the data in a table storage model and access it using the various Azure SDKs. Alternatively, you can set it up as a Cassandra instance and access your data store using Cassandra's API. Alternatively, you can create a document database and manage documents using either the MongoDB SDK and protocols or the Microsoft API. Clearly, this is a service-based offering that provides an extremely flexible model for storing your data. To take advantage of the fact that Azure Cosmos DB can store data in multiple models, you may want to use it. In other words, multiple masters in different regions can be used, synchronization between nodes is fast, and you can select from 5 different levels of consistency. This kind of system usually requires a trade-off between immediate consistency and slow performance or long-term consistency and faster performance. You can adjust the sliding scale of Azure Cosmos DB to fit your specific needs by selecting from 5 different levels. With Azure Cosmos DB, it's possible to choose the data model and APIs you want to interact with the data store, as well as a globally distributed system that's built for the cloud. Finally, when discussing data storage, I'd like to touch on Azure Data Lakes version 2, which is what I'm referring to here. Using a large-scale data storage like this, we can begin to move toward analytics and analytics tools. File-based or blob-based access is available via the Azure Blob Storage platform. The two models aren't just layered on top of each other, they're distinct from each other. This data lake has been optimized for both file-based and blob API access, so analytics tools can use either to access the files or blobs in it. This means that you get the benefits of blob storage and all that comes with it, including the ability to put data into an archive or cold storage that you don't use as frequently to save money. So, as you can see, each of these options has been specifically designed to meet the demands of cloud-scale application and analytics development. A brief discussion of data processing is warranted, since we now have a plethora of information that needs to be moved around. There will be times when you only need to ingest or process data from your applications, and for those times, we have event hubs. Your messages and data will be put into your data storage using this scalable ingestion model. If you need to move that data, you can do so now, but you can also put it in a data lake or blob storage. And, as previously stated, it is designed to handle large amounts of data from a variety of sources, including telemetry and other systems sending data to your hub. For moving data or performing extract, transform, and load (ETL) processes, we now have Data Factory. SIs and DTS are cloud versions of SQL Server's SIs and DTS, respectively. However, this is more than just a cloud version, it's about loading data from various systems and even different clouds, cloud providers, and then processing it in other systems. One of the examples we will look at is a cloud web application that you're building for the cloud, and we will see how this fits into the larger picture. You could use Azure Cosmos DB to store your product catalog or other types of data that are better suited to being stored in a document database format. Table storage can also be used to store additional information. In the event that you have a large amount of data that needs to be indexed, you may be able to select the specific rows and values that you are interested in. Finally, blob storage can be used to store your images. To get the best performance for your application and your clients, you'll be able to store these in a globally available storage option with the ability to perform caching and other optimizations in front of that blob storage. As a result, even in a simple web application, a wide range of data storage options may be employed. Alternatively, you may be moving a web application from an in-house set of web servers and databases to Azure and want to pick it up and transfer it. Using Azure SQL as your relational data store and the various Azure SQL offerings to ensure the best compatibility is possible. In a migration scenario, your web application may be using the normal file APIs to access files. With this, you can provide your web application with an SMB view of a share that is accessible through the Azure storage system and the Azure files that sit on top of it. Using the same file APIs is still possible. Many times, all that needs to be done is to alter the route. Because it's stored in a storage account, you can access it from any of your web application's nodes or instances as it grows. When it comes to data processing, you may want to abstract data from your own on-premise data center, or you may want to pull data from another cloud, such as a blob system, log files, or another data source, and then use Azure Data Factory to process it. Lastly, we can look at an example of data processing. In this case, you can set up Data Factory to pull data from these sources and then send the transformed data to an Azure SQL database or a data lake where it can be processed by your applications or by some analytics. You can pull and push data to and from Data Factory, as well as perform all kinds of transformations in between. I hope that through the explanations and examples, I have given you a sense of how you can take advantage of those different storage capabilities for different application needs, as we have looked at storage options, so that you can focus on developing your applications and analytics rather than on maintaining infrastructure and database server installations. I recommend using those cloud-managed or service-based databases, if at all possible. Think about how data lakes, which are specifically designed and optimized for analytic tools, might fit into your solution and how that might meet your analytics needs as you think about and plan for analytics. With Azure, you have access to a wide range of data processing tools, such as Data Factory and Event Hubs, as well as a wide range of data storage options. These tools are all included in your Azure subscription and can be used to work with all of your different data sources and store data for building your applications. After that, we will take a look at Azure's data analytics capabilities and some of the tools available to you. We have spent a lot of time talking about data collection and storage. Once you have collected the data, it's critical that you analyze it to gain a deeper understanding of your company, your clients, and your employees. That data has to be understandable, no matter what it is about. We will also go over some of Microsoft's Azure machine learning offerings so that you know what you can do with them on top of the data you're collecting, in the hopes of demystifying machine learning a little bit. As a matter of course, we'd like to know how to present the data. Most of the importance of data analysis lies in making it understandable to the end user so that they can derive maximum benefit and have the most actionable data at their fingertips. If you have worked with data analytics in your data center or SQL server before, you might recognize a few of the services available inside Azure. A cloud-optimized data warehouse, SQL Data Warehouse, makes use of the cloud's infrastructure to store data. The cloud data warehouse is going to be provisioned and we will get started. Servers, drives, and clustering don't need to be set up. We have just set up that data warehouse, and now we can take advantage of all the hardware and the increased speed and reliability it brings. Additional analysis services are available. You may recall working with something like this in SQL Server. Analysis services projects can be built using Visual Studio tools. Using the SQL data warehouse or other stores, you can manipulate the data and build models that make sense to your end users so that they can query and find the data they need to do their jobs. Data storage and analysis will be handled by these two services. Analyzing data as it is processed or ingested into the system is the goal of stream analytics, which takes a different approach. Real-time analysis of data. With time slices and chunks of telemetry data, you can analyze what's going on at a warehouse or system level as it's streamed through the system. Moreover, this is extremely well suited to handling large volumes of messages. This means that the system is designed to handle streaming and to process messages as they move through the system. Stream analytics follows this pattern. Data is ingested, analyzed in the stream, and then the results of the analysis are output. After that, you'll run the analysis on the data to produce some recommendations or decisions for your users within your application. If you're talking about analytics, chances are you'll hear about Azure HD Insight. This allows you to run a variety of open-source analytics tools such as Apache Spark, Hadoop, Hive, Storm, Kafka, or HBase in a cluster environment. In this case, you create a cluster, decide on the type of cluster it is, and then provision that. You can simply create a cluster and provision these tools using Microsoft's service, so you don't have to go out and set up servers, storage and networking and install these things and get them running. These are open-source tools used for analytics on big data. When it comes to big data processing, it's more important to focus on getting to your application quickly and doing your data analytics than it is to build out infrastructure and use the cloud infrastructure to dynamically scale these clusters. Azure Databricks is a cloud-optimized implementation of the open-source concept. What you have is an Apache Spark service that has been optimized for the cloud, with a variety of tools to help you take advantage of that infrastructure. Apache Spark can be used in the cloud first because of its deep integration with many Azure services, such as Active Directory for identity management and role-based access control. It is important to note that while HD Insight allows you to create clusters of a wide variety of tools, the Databricks service is a focused offering that works with the people behind the open-source frameworks that it supports, making it the best experience possible. Machine learning has recently emerged as a key component in discussions about analytics, or the study of data and the attempt to make sense of it. As a result, Microsoft's machine learning strategy allows you to begin at any level. A beginner can get up and running with machine learning in a matter of minutes, but an experienced data scientist has access to a variety of tools that allow him or her to get deep into programming languages and select their own algorithms and plug them in. This is what you'll do with machine learning: build and train models. To put it another way, you'll use data that you already have and train models on it to generate answers to your questions. Once you have built your machine learning models, you can use a DevOps experience to deploy and manage them directly from the machine learning system, giving you complete control over how your models are deployed and updated. You can then use these models in your applications to take advantage of machine learning and answer the questions they pose. As a starting point, Cognitive Services is a great set of services that can help you get started with machine learning without having to build all those models. There are a variety of services available for analyzing data and making decisions, including text-to-audio and audio-to-written text conversions. As a result of the Cognitive Services vision and the Bing search services, you can create thumbnails or search for specific things or people in images, and you can use these APIs to perform a wide range of searches based on these APIs. This means that you don't have to build a model and create a whole set of algorithms, and you can start using these services right away by provisioning cognitive services in your subscription and start using the Vision API right away, sending images over and getting back results, or using the language service to send text over and get sentiment analysis right away. If you're just getting started with machine learning, this is a great starting point. You'll need to show your users the data you have analyzed with these other tools, and that's where Power BI comes into the picture. From the desktop client that you can download to the Power BI embedded, you can embed rich charts and analysis visuals into your application. Power BI has a lot to offer. Once you have completed your analysis, look into Power BI's various offerings for internal use within your company, for mobile, and for embedding in your application, so that you can provide those visualizations to key players who require them. You probably think I promised to simplify things at the outset of this course, and now you have just laid out a slew of resources for me to use in doing analytics. While it's true that Azure provides the tools you need to tackle any scenario, if you're struggling to put it all together because you don't know where to start or how to do it, Azure Synapse can help you get your bearings. In order to help you manage things like SQL data warehouse or Databricks from a single location, Azure Synapse Analytics was created. So this is a combination of different storage and different analytics tools. Azure Synapse pulls in all of your storage, whether it's in blob containers or data lakes, whether you have got files or structured data, and all of that storage can be used for ETL or data movement, extraction, transformation, and loading. A single tool can be used for all of these different tasks, including ingesting data and processing it through various pipelines. This means you don't need a separate tool for each of these separate tasks. However, this tool does not replace the other things we have discussed, but it helps unify them into a single workspace where you can manage the storage, movement, and analytics of your data from a single point of entry. Consider a couple of simple examples to help you make sense of this. Our data factory discussed in the previous module can be used to extract data from various sources and then load it into our SQL data warehouse. This is a simple example. Using analysis services on top of this is a fairly common pattern, and you can then create some models that make sense for your users. We can, of course, start plugging in Power BI right away. After we have done the analysis services, we will be able to pull that data into a model, and we will be able to show it visually to the users. We can also combine stream analytics with machine learning, as an example. The event hubs we discussed earlier could be used to ingest a lot of data. IoT hubs, Kafka, and other tools can also be used to bring in data. After that, we can run it through our stream analytics to see if there are any interesting patterns. Our stream analytics can be integrated with a machine learning model as part of this. So it can analyze the data, use what we have learned from training the model to get the results you need, and then output that data into a data store. In this diagram, I have shown it as an Azure Cosmos DB that we could make use of within our app. It's possible to store it in a data lake. Your application can now consume the results of the analysis done in stream analytics and the machine learning models if you store it in a SQL server or any other data store that makes sense for your application. We have looked at a variety of analytics tools, and analytics are becoming increasingly important as we amass ever-increasing amounts of data. Ordering and managing it in such a way that it can be consumed by the end user is critical to its success. The most difficult part is making sense of all the information. We have got data warehouse and analytics tools built to handle and benefit from cloud scale in Azure. They are designed to be simple to set up, scalable automatically, and safe from failure. For these big data workloads, the tooling we have supports the ability to analyze huge amounts of data and whittle it down to the key pieces of information that will be most valuable for those people or systems who are going to use this information and get better results. It's worth noting that Microsoft has embraced the open source tools that are now available. Rather than trying to replace open source analytics tools, HD Insight and Databricks are working to build a cloud infrastructure that makes it easier to get started using them. What does it mean to integrate cloud-based applications? That's what we will cover in this module. Integrating messaging and workflow will be a focus of this section, which will also touch on the additional capabilities and requirements that come with it. When I discuss integration, I'm primarily referring to the linking of various systems and programs. There are a number of ways that you can connect your Azure app to your own data center, as well as connecting it to a web application via an API, either your own or that of a third-party service. Even if you have done this, you know that the definition is simple, but implementation can be extremely complicated. Integrations within a cloud are also possible in the cloud, but this is not the case in the traditional sense of the term. A web application's API or messages exchanged between application nodes are both viable options. Integrating the cloud with your own data center is also an option if you are in need of accessing or sending information back and forth. It's possible that you're integrating between different clouds. This could be from one Azure region to another or from a region to an application hosted on Amazon or Google Cloud. And, as is becoming increasingly common, you may have a cloud-deployed application that requires integration or connection to one or more software as a service applications in order to benefit from their functionality, business logic, or data. Messages and data are exchanged back and forth between nodes as part of most integrations. Contrary to popular belief, these are not the same things at all. Allow me to explain. The Azure Service Bus is a critical component of any discussion of messaging in Azure. And the Service Bus is built to either do relayed messaging, where nodes communicate with each other by relaying messages through the Service Bus, or brokered messaging, where a message is sent to the Service Bus where it can be queued up for delivery to one or more clients that have requested that message. In the brokered messaging subsystem, there is a very extensive publish and subscribe model. This is the publish and subscribe event notification system I briefly mentioned earlier. The semantics are now open for debate. However, when I think of events, the primary function is to inform you of what has occurred. A message's primary function is to transfer data from one system to another. As a result, the event grid's primary objective is to alert you to events that occur in your Azure infrastructure, applications, or any other Azure services. Then you may process that by going out to blob storage and doing something and then sending a message to another system, for example. Another service we offer is API management, which is all about assisting you in publishing APIs, safeguarding them, and overseeing their management. The ability to create developer portals or documentation of APIs is one example. You can also use this to create composite APIs, which allow you to define a client interface or API surface that actually composes different operations or interactions with a variety of services on the backend. Azure Logic apps are a great way to manage all of that messaging and get it all done in a timely manner. A workflow engine is provided to orchestrate these various messaging interactions. They show you how the messages in your process flow from one to the next. An event from the event grid may serve as a starting point, but the next step in your business process, as well as the systems with which you communicate and the actions taken as a result of those communications, are all part of the workflow. To summarize, Logic Apps gives you the option of describing your business processes visually or through JSO, and then connects to hundreds of different types of systems in the Azure cloud, other clouds, SaaS, and your own data center with ease. An integration account can be used to extend Logic Apps. With integration, you'll be able to get some of the features you need. Enterprise file formats, such as comma-separated files or AD documents, may seem like an oxymoron when I say things like those, but they are very commonly used. XSLT or liquid templates can be used to transform XML or JSON, for example, from an AD file to JSON or from a CSV file to XML. As a result, you'll be in charge of managing your partners, including things like certificates, endpoints, and defining agreements between your organization and theirs. All are a part of the accounts for integration. Schemas exist for the various types of files you'll be exchanging. These transformations can be applied to the maps you have already created. Agreements are the glue that hold everything together. Your logic apps can also incorporate all or a portion of these integration features as you manage the various exchanges. We will examine a few examples. A service bus relay is one of my favorites. As you can see, these two servers are located into distinct data centers. One is in your data center, the other is in a data center belonging to a partner organization. Additionally, you'll want to be able to communicate with the other devices. However, as you may have guessed, they're both behind firewalls because that's just good practice. Both servers cannot simply reach out and establish a connection with each other. Both servers can communicate with each other through a cloud-based service called Service Bus Relay. The service bus can be accessed by either my server or your server in your data center via an outbound connection from the firewall. The service bus can also be accessed by the partner server through the firewall. Since then, we have established a safe channel for exchanging data between the two application servers. Messages can be secured from beginning to end so that only the intended recipient can read them, with no interference from the service bus or any other third party. Because of that, you can connect those systems across the internet and deal with some very difficult connection issues that can arise in a real-world scenario. Instead of a real-time connection, the message would be stored on the service bus until it could be retrieved and processed by the client, which would make this a brokered scenario rather than a real-time connection. Example 2. In order to perform some processing, you might have a logic app associated with your integration account. You receive the AD file via secure FTP and start your workflow or your logic app with the integration account, but what if you don't? An AD document is defined in terms of a schema in the integration account. You can now use a custom connector in logic apps to send data to an internal system that doesn't have a built-in connector, using a schema and possibly applying a map to get some XML. There's a good chance that whatever system you're using has a driver for it. It's possible to transform that document into a JSON document and send it over HTTPS to a service provider or another endpoint. It's up to you to decide how the logic app handles those steps, whether they're sequential or concurrent, and whether the response from one dictates the actions of the other. Integration is about linking systems, which necessitates the use of messages. Variations in security and protocols are common. Here, messaging and workflow play a key role in making those connections and securely passing data. It's all possible thanks to Azure's logic apps, which allow you to orchestrate all of these interactions. When you're integrating with a lot of different systems, you'll need a wide range of additional features, such as file formats that are supported, transformations, and partner management. Finally, we're ready to dive into Azure's networking now that the integration process is complete. To get things started, let's talk about cloud networking. Compared to a data center where you manage your own physical hardware and Ethernet cables, what is it like to create networks in the cloud? We will go over virtual networks, which are an essential component of any Azure networking setup. When it comes to connecting your Azure resources to your data center, we will discuss VPN connections and the various methods you can use to accomplish this goal. Additionally, Azure provides a variety of networking services that you can use as you build your solutions. Now, you may recall that I said something to the effect that when you're working in Azure, you don't have to worry about infrastructure. And now, I'm telling you, you've got to set up networks and manage these things yourself. If it makes sense for your solution, you can choose to use virtual networks. You don't have to get into the complex details to come up with a solution. There are many other options. There is no need to manage virtual networks and firewalls and load balancers and all that stuff if you don't want to when you scale out a web application to multiple instances. When you decide to make use of your computer's networking capabilities, we will go over the choices you have. Virtual networks, as I mentioned earlier, are a key part of Azure's networking and allow you to define a network. In that you're setting up your network subnets and other information, they're not that different from what you'd expect. Because they are all virtual and only defined in the Azure data centers, there is a difference. What this means is that you can set up a wide range of related things. If you'd like a public IP address, you can request one and have it set up. Using an IP address, you can make a machine or instance reachable by the general public. Setting up security groups is obviously an important part of keeping your network safe. What ports and destinations are allowed to send traffic from my network? Is there a list of protocols that can be used? Using application security groups, you can avoid defining this for each and every virtual machine or service that's currently running. You can group things together and set rules for network traffic. We also have policies in place for service endpoints. For example, consider blob storage or SQL databases. For example, you may want to use it in your Azure web application. In this case, it's possible that you don't want the blob storage data exposed publicly. For example, you can create a service endpoint policy that restricts access to a specific set of data in your Azure blob storage to a specific virtual network, giving you greater security and control over what can access that data. There are a number of additional services that can be extremely helpful in addition to the networking components. Connecting Azure resources to on-premises resources is a common requirement for many users. As an option, you can also use ExpressRoute, which is a virtual private network, VPN. An on-premise data gateway is another option. If you only need access to a single server or application in your data center, for example, then you don't need an entire network. In order to communicate with the limited number of services available, you simply require a gateway. We have a variety of additional network services that you can use in addition to those networks. Caching data close to your customers through a content delivery network, CDN. If you want to get your customers to a location that's closest to them or to distribute the load across regions more evenly, you'll need a traffic management tool that lets you write rules and manage traffic. There are load balancers that can be set up and configured by the administrator. There is some automatic load balancing, but you can create and manage your own load balancers if necessary. Finally, you can configure DNS and DNS zones within your Azure environment. There are many options for resolving host names without having to deal with IP addresses, such as using DNS. Naturally, security and the impact of making a resource available on the internet are on everyone's mind when building a solution in the cloud. For example, denial of service protection and an application gateway let you set up a front end for tasks like SSL offloading and traffic management across regions, among other services. For the front door, there is a microservices front door service that helps you manage the security, load, and traffic of your system. Check out these case studies for some ideas on how to make use of these networking tools. It's possible that you're constructing a hybrid network. If you're building a cloud-based web application, you may want to be able to talk to a service in your data center. As a web application, ExpressRoute can be used in conjunction with a VPN connection to connect your web application to a virtual network hosted in Azure and your data center, allowing the two to communicate with each other. Alternatively, you could implement a full cloud solution. So you're using Azure to create a web app that runs in the cloud. Your network may be spread out across multiple locations. You can use Traffic Manager to ensure that customers are routed to the closest node or instance, or you can do round robin or disaster recovery across regions with Traffic Manager in front of it. You can also use blob storage to store images and large files that are part of that web application. Caching is a great way to get the best performance and experience for your customers, so you can use a content delivery network, CDN, to take advantage of that. Finally, keep in mind that you can create a virtual network specifically for your web app. There's a good chance you'll be gaining access to some type of data. It's possible that you'd prefer to use a service endpoint policy to ensure that only your virtual network can access the data source. As a result, you can use it to help secure your environment and manage network connections between your various resources. For this reason, we should focus on cloud networking as a way to link up your resources while also giving you the ability to manage data flow through Azure networks and between them. There are numerous robust networking options for caching, security, and data routing over those networks. To manage the connections between resources, such as service endpoint policies and the virtual networks, you can take advantage of these various options for managing connections. If you want to connect your Azure resources to resources located in a data center outside of Azure, you can use ExpressRoute or one of those gateways. There are a number of options here that you can use with Microsoft Azure to fit the different requirements or different solution designs that you come up with, and you can use one or many of these options together to get the end result that you need. We will cover some of the management tools that are available in Azure to help you provision, decommission, and manage your resources. In this section, we will cover various management aspects, including familiar tools like a backup, and new and unique features that are only available in the cloud. For this purpose, you'll learn about how to monitor your virtual machines, services, and containers in Azure to ensure that everything is running as planned while your applications are being used by your customers. Understanding the concept of your Azure subscriptions and accounts is critical from the outset. Now, when you create an account, you have the option of creating a management group that serves as a container for additional management groups or subscriptions. Marketing has a subscription under the root management group, as you can see here. The marketing department will be able to take control of the subscription's resources once I assign it to them. QA test production subscriptions are part of its development group, while operations subscriptions are managed by the IT department. As a result, I can organize all of my resources hierarchically and control who has access to and control over those resources. As you begin to plan your organization's account and the various subscriptions you'll manage within it, it's beneficial to have an understanding of this. It's possible to use a variety of tools to manage your resources and build your solutions when you're ready to do so. As a web-based tool, the Azure portal can be used to manage and monitor all of your resources in the cloud. There are individual views of your resources in the form of so-called blades in this very robust web application. You can also manage your resources via the cross-platform command line interface or PowerShell tools. It's also possible to use the Cloud Shell instead of installing the necessary tools in order to run commands from the command line. Using the portal, you'll be able to access a command line interface that lets you use all of the command line tools and commands without having to install any additional software. There is also the mobile app, of course. As an example, if you're out of the office and need to check on things or take some quick actions, you can use the mobile app to do that. There is a REST API at the heart of these tools, and they all use it to manage these resources. There are a variety of ways to get your work done, but they are all managed by the same system. When it comes to setting up and managing your environment, there are a wide range of tasks that you must complete. Start thinking about site backups and disaster recovery as well. As a result, Azure is equipped with disaster recovery capabilities. It has cloud-based site recovery and recovery vaults that allow you to store and restore data in the event of a disaster. For some of those backups, you have the option of storing them in the cloud or in your own data center. Scheduling and automation are both options. As a result, you can create runbooks that specify a sequence of events that must occur. Additionally, you have the option of executing these runbooks on demand or by using a powerful scheduling tool to plan out a variety of different tasks. These management groups and subscriptions come in handy when it comes time to define policy because you can do so at various levels. So, you can say this is the IT policy. Marketing, sales, or operations, this is the policy for the other division. Controlling who can access your resources is a must with all of these tools and capabilities available. With role-based access control or RBAC, you can define through policies or individual steps or a part of your deployment who can take certain actions or work with these different resources that you're setting up in Azure, and you can do this across all of the different resources and management features. For your governance and compliance needs, we have included auditing and logging as part of the process. Deploying or provisioning Azure resources is an important part of Azure resource management. You could, of course, use any of the tools we discussed to provision a single resource, such as a virtual machine. Rather, you can use a template file to find in JSON and describe a number of different resources, what resource group they'll go into, what locations or data centers, and the various services that go along with them in Azure Resource Manager. As a result, you could create a web application and a SQL database, and then set up a connection string between the two, or you could create a logic app and all of its connections, and then deploy it to your environment. These templates can also be customized by changing the parameters. A template could be used in a development, QA and production environments using the same code. To get the results you want in that environment, we'd simply change the parameters we use. There are many resources that make up your solution that can be deployed using this template in a repeatable manner. For example, an app service for your web app can be deployed using this template. For those deployments, Azure Resource Manager is an excellent option. At the time of this recording, Azure Deployment Manager is in preview, which takes the Resource Manager one level up and gives you the ability to coordinate resource deployments. As a result, a service topology can be defined in conjunction with a template for the specific resources to be deployed. As a result, you may be able to use the same template in multiple regions, each with its own set of parameters. A web layer ARM template and an API layer ARM template, for example, could be included in your services. You'll also be in charge of deciding how the rollout will proceed. After Region 1 is completed, we plan to roll out the same template and services in Region 2 based on the results of the first region. In other words, these tools are all about making it easier for you to repeat and manage your process for deploying a set of Azure resources. In order to know when something is working properly and when there are problems with your application, you'll need to monitor it. There are monitoring and alerts in place for this purpose. Azure Monitor provides a wealth of information about the health of your application. In order to keep track of all the components that make up a cloud application, from web applications to possible microservices, and the data layer and other storage options out there to all of the virtual networking and logic apps, you'll need an integrated monitor. Tools like Network Watcher are also available to us. In the past, You may have had to install a third-party network tracing tool on a virtual machine or a server and then use that to capture traffic, which raises concerns about the impact on production. Having all of our networks virtualized on Azure, Network Watcher can simply plug in and monitor some of the traffic for you. Because you probably won't have the time to constantly monitor the portal or mobile app, you have the option of setting up alerts. In this way, you can be alerted whenever something happens that crosses a predetermined level of significance in the environment, and thus, you can take action and remedy the situation. As an illustration, consider the following situation. It's possible that you'd like to deploy and monitor your app. What would that entail? You can use your JSON and ARM templates, as well as the various tools we discussed, such as the portal, PowerShell, and the command line, to deploy the templates and any parameters you want and create a resource group to hold them. Your solution will benefit from this logical grouping of various resources. A single JSON file could create a storage account, an Azure web application, an Azure function, an Azure logic app, and so on in a repeatable manner so that we can provision and create our environments over and over. This will allow us to begin collecting data in Azure Monitor and receive notifications if anything unusual occurs. We're alerted if our logic app has a failed test. If there are problems in your environment, you want to know about them. Automated updates are another possible example. So you're going to use that scheduler to figure out exactly when you want to get started on this project. You'll use one of the automation runbooks you have defined to check on the status of your Windows or Linux virtual machines. Keep your environment up to date by having them patched and updated. As you can see, there are a variety of management tools available in Azure. It's no longer enough to just go out and get resources to be a manager nowadays. Azure deployments with complex solutions that require large amounts of resources necessitate complex management tools. Our concern is with being able to utilize all of the available resources. In addition to deploying code, we will cover developer tools in the next section. Virtual machines, web hosts, and containers all need to be able to be deployed and provisioned. To keep things patched, you'll need to be able to monitor that and perform the day-to-day operations to ensure that everything is up to date and running smoothly. And as Azure has grown, so have the management tools to give you the same and, in many cases, better experiences than you would have managing an environment in a data center. Using Azure as an example, I will go over the various development tools available to you, as well as the various tools that Azure itself provides. Azure provides a variety of tools and technologies to help you develop on the platform, including a variety of languages and frameworks, as well as a variety of tools. Developing for Azure has a number of advantages, the most important of which is that it is an open platform for a wide range of technologies, rather than being exclusive to Microsoft. As a result, you can access the REST or web APIs of the vast majority of the services on offer. This means that if you can send an HTTP request and create an HTTP request, you can probably interact with those services, such as the storage service, logic apps, functions, and management. Microsoft provides client SDKs to wrap those APIs interface tailored to the programming language, so things such as HTTP requests and asynchronous work follow the common patterns on those platforms and with those languages. This is not what most developers want to do, so that's why Microsoft provides those SDKs. While there are a few things that can be developed directly in the portal, such as logic apps and Azure functions, most of those have a mechanism for you to develop outside the portal in a development environment or at the very least integrate them into your build and deployment pipeline. Development for Azure is impossible without the SDKs. Making HTTP requests and making sure all of the headers are correct is a time-consuming and error-prone process. SDKs written in your programming language simplify and wrap up the complexities that you face. Developer tools are another area where you have options. However, you can use any other developer tool to work with Azure. Some are more tightly integrated with Azure than others, but the choice is ultimately yours. Microsoft's tools will certainly work and provide a lot of functionality. When it comes to modern technology, container development is a hot topic, but getting started and understanding all the moving parts is a bit of a challenge, and Microsoft has made it easier for you in their tooling to make it easier for you to simplify individual and team development for containers. When you're done developing, you'll have to figure out how to build and deploy your app. In the Azure Resource Manager, we can use ARM templates to provision the environment. For this purpose, you can use a variety of tools, some of which are provided by Microsoft, in order to deploy your application. In some cases, you can simply use the tools you already have at your disposal. Those SDKs are multilingual friendly. Developing for Azure shouldn't be limited to those with experience in .NET or Microsoft technologies, as previously stated. And Java and Node.js are also included in the list of SDKs that are available. For cross-platform development, many of these SDKs have been built to be cross-platform, so if the language that you're working on is cross-platform, the SDK itself has been built to be cross-platform as well. This makes it much easier to manage, and it's especially important if your team includes people working on Windows and Mac. One thing to keep in mind is that the SDK's service coverage varies depending on the languages they support. .NET, Node.js, and Java all have a wide range of users. The SDKs for some of the other languages are tailored to their most common use cases in Azure. Remember to check the documentation provided with the SDKs to see what services are available directly in your language, and if not, you can still use the HTTP model and avoid the REST API entirely. Of course, Visual Studio is an excellent tool for working with Azure. The workload for Azure or cloud development is directly supported, so you can create projects that target Azure for Service Fabric or Logic apps and at the cloud workload. You can also find extensions for Visual Studio for other services and get integrated tooling inside Visual Studio for viewing and managing your resources. So, for example, you can go and find your Azure app service in a tool window. However, there is also support for the Eclipse development environment. It is possible to add Azure-specific functionality for managing and deploying an application using Eclipse plugins. For Java developers using Eclipse, there are some tools available. Many Node.js developers have begun using Microsoft's free and open-source Visual Studio Code, a lighter version of the company's flagship code editor. There are a number of extensions available for JS, JavaScript, and Visual Studio Code that can help with everything from IntelliSense or template help with code files and code editing, to extensions that let you browse and work with your Azure resources to the point that you can right-click and deploy the code from Visual Studio Code. As a Java developer, IntelliJ has Azure extensions that can be used for specific tasks, such as setting up and testing a web application in Azure before making it available to the public. This is by no means a comprehensive list, so if you have a favorite tool for editing your code, feel free to stick with it. Once you have tested the code locally, you can then integrate the SDKs into the build and deployment process by using the package manager of your choice, depending on the language you're using. Containers, as previously mentioned, are rapidly gaining popularity as a model for packaging and deploying software applications. For local development, you typically use Docker to run containers locally so that you can perform local testing within the container package and ensure that you're not testing completely outside of the environment you're aiming to test. It's possible to run integration tests in the cloud using Kubernetes in Azure, and this is a good option in many cases. Then there are Azure Dev Spaces, created by Microsoft. On top of the Azure Kubernetes service, they built this. As a result, you'll be building for the cloud in the cloud. You have an Azure Kubernetes service cluster provisioned and running. You have the ability to deploy and make use of your application. As a result, the team has the ability to work on multiple services at once. So if I'm working on one service, I can write some code on my local machine. When it's ready, I can run it in Azure Kubernetes service against the other services or parts of the application that have already been installed and deployed. And you may have multiple developers working on different services, each in a separate branch of execution. As a result, it's geared toward a team of developers who want to collaborate on a shared code base in the Azure dev space. You can, however, use that environment to test and refine the code you're currently writing. To put it another way, you aren't conducting your experiments in a vacuum. Mocks aren't required for testing. Using Azure Dev Spaces, you're testing against the code that is currently running. It's worth a look if you're planning to use Kubernetes for container development and you're not sure if it's a good fit. Even though some developer tools allow you to right-click and deploy code, that's probably not how things are done in production, as I mentioned earlier. Using tools you're already familiar with is a huge advantage when using Azure. That means you'll likely be able to keep using your current build system for continuous integration and continuous delivery if you already have one. You also have a variety of options for deploying. Git is a great way to store your code, so you can take advantage of it. When a check-in occurs on a known branch in Azure, that code is pushed to, for example, your app service or your web application and deployed to production. These ARM templates can also be used. ARM templates and parameter files can be pulled out of source control, Azure can be accessed, and the environment you are targeting can be provisioned before your code can be deployed, regardless of the tool you use to build and deploy it. It's possible to continue to use your current build process and just add in the steps for pushing things to Azure. However, Azure DevOps, a complete set of tools for the software development lifecycle, is also part of Azure and can be utilized by your organization if it makes sense. Azure boards are available for use at our facility. This is where you keep track of all of your projects, tasks, and bugs. You can then use Kanban-style boards to manage your projects on top of these. It is possible to store your files in Azure repositories and manage them with Git or the Team Foundation version control model if you have previously used Team Foundation Server on-premises. Build and release pipelines provided by Azure Pipelines allow you to perform builds on Azure servers or your own servers and then distribute the code to various environments. In addition, there are a number of tasks that must be completed before your code can be released or deployed to various Azure resources, such as containers, web apps, or virtual machines. In addition, you can use Azure test plans to document and track test plans for your code, including how it will be tested and what the different results will be. As a result, you can use Azure DevOps for those services even if you don't require the full software development lifecycle toolset. Let's take a look at a couple of real-world scenarios so you can get a better idea of the coding options available to you in Azure. If you want to write code in Node.js using Visual Studio Code, this could be a simple solution. In the end, you'll want to deploy the code to an Azure app service. Visual Studio Code extensions allow you to provision and deploy an app service directly from Visual Studio Code. However, you can use a more comprehensive build and release process that incorporates non-Microsoft tools and frameworks like Node.js and Git, as well as a third-party service provider, instead of just checking in code from Visual Studio Code into a Git repository. This will achieve a similar result to publishing the code to the Azure App Service. Making use of microservices is yet another example. Visual Studio can be used to create your services, check them into a repository in Azure DevOps, and then use a build and release pipeline to take that source code, build it for you, and create container instances that you store in Azure Container Registry. A Kubernetes service is then created for you by your release, and you can start using it right away. To run and host these containers, they are retrieved via a registry from which they can be downloaded. Again, different steps in the process, such as the repository you use or the build and deployment tool, can be substituted for each other. However, the principles of how you use your development tools remain the same. You make use of the tools you have developed and deployed. These resources are pushed into Azure, such as an app service or a Kubernetes service, as well as your code, using the deployment capabilities available. So far, we have discussed some of the developer tools and SDKs. What I want you to know is that Microsoft is trying to build tools that work across platforms and languages. In order to provide cross-platform and cross-language accessibility, the Azure platform itself makes use of HTTP-accessible APIs. To make things even better, SDKs and other developer tools are available. One of the great things about containers is that we have a wealth of tools and unique experiences like the Azure Dev Spaces that make working with containers a lot easier. Azure DevOps tools are available, as well as the tools that you may already be using on your own servers and in your other hosted environments for full support of the software development lifecycle. The Azure Cloud Security will be our next topic of discussion. When identifying your users and keeping track of their logins, we will cover this topic in this module. If you have documents or encryption keys or any other type of secret that you must manage and work within your applications, we will also take a look at how to protect them. After that, we will talk about how to secure your applications, how users can log in, and how those applications can be linked to directory services or identities. It should come as no surprise to anyone who has worked with Microsoft in the past that Active Directory plays a significant role in Azure's identity story. For the cloud, we use Azure Active Directory, a specific implementation. Using its directory services, you can keep track of all your users and their associated personal data. Aside from requiring a username and password, you can also require users to prove they have access to a specific hardware device when they authenticate. This is possible with multi-factor authentication. Text messaging with a code or using an authentication app on your phone are two common examples of utilizing your phone as an additional layer of security. Syncing with your directory is one of the great features of Azure Active Directory. Since Active Directory already exists in data centers and can be used to log users in, you can sync your existing Active Directory users out to an Azure Active Directory and allow them to log into your Azure-based resources. Companies that use Office 365 to sync users between the cloud and on-premises servers are doing so in increasing numbers. Azure AD Domain Services, or Azure Active Directory Domain Services, are a part of Active Directory, along with the core services I mentioned earlier. To enable computers to join an Active Directory domain, you typically use domain services, which enable computers to join an Active Directory domain and become a part of that directory. Your virtual machines can be added to the domain using Azure AD Domain Services. So we don't have to provision virtual machines and create an Active Directory node in order to install all of the roles. Azure AD Domain Services can be set up to do this for you. Azure AD B2C, or business to consumer, is another option. In addition, this is an identity story for the applications or endpoints that you'll be exposing to customers or partners outside of your own directory. As a result, it allows you to use a username and password to log in, but provides you with the backbone of Active Directory to store all of that data. It's also possible to let users authenticate using social media or Microsoft accounts. As a result, You can offer a wide range of login and identity service options to your customers while still utilizing Active Directory's tried and true directory services. Your applications will use this identity information to build and deploy in Azure, which is a major part of the Azure platform's functionality. A managed identity is one of the services that can be used. That's why it's possible to run your application and have it access Azure resources using a specific identity. In the same way that you might set up an application pool identity in IIS or a service account for a Windows service in your own data center, you can think of this. In addition, this will greatly facilitate the safekeeping of sensitive data while allowing your application to have limited access to it. As part of your Azure subscription, you can also register applications in your Active Directory. In order to grant access to your users, you must register the application in the Active Directory, providing callback URI and other critical information that ensures that only the applications you have set up and approved use your directory to authenticate those users' identities. And then there are enterprise applications, which accomplish the same thing. It's possible that you have never written any of these applications. This is a scenario in which you have paid for some third-party SaaS application and you're using your Active Directory credentials to log into the service. Those applications will also appear in your subscription under your directory, where you'll be able to manage them and recollect which applications authenticate against your directory. You also need to safeguard your company's data in addition to identifying and authenticating users. You can connect your Office 365 and Office tools with information protection so that you can protect your documents, emails, and other data that you're creating. Classification and labeling of data as it is created is made easier with a comprehensive set of tools and some pre-configured settings. This data is further protected across all tools and platforms, even when it leaves your systems to travel to other locations. Cross-platform and mobile device access to that information is also supported. There are many ways to protect email content for compliance and regulatory reasons, and this is one of the most effective. Key Vault is another feature available to us. When it comes to storing secrets like encryption keys that you need to use to access information but don't feel comfortable storing them in a config file or your code, Key Vault is exactly what you have been looking for. Then, with Key Vault, you can store them securely, and you can grant access to specific applications or identities so that you can use them in your code at runtime. Key Vault can be accessed by drilling into the vault, where you can get your hands on some actual keys that are being used to protect the vault's data. Additionally, you can request and set up a hardware-based security module in an Azure Cloud data center directly connected to your virtual networks in order to further secure your virtual networks from external threats. This is an actual hardware device that stores your keys and information and is only accessible to the subscription you have with the service. Even Microsoft is unable to get into the HSM to use your keys. All the way from documents to encryption keys, there are a variety of options for protecting data. A cross-cutting view of your environment's security concerns is easier to come by as you begin to manage the security of an Azure subscription and as the subscription becomes more complicated. In other words, you can use it to keep tabs on your virtual machines and software. Using this tool, you can find out if your virtual machines are missing critical patches or if you have open ports on the virtual machine setup and its networking. It's possible to check your web applications to see if certain ports are enabled and if SSL is enabled as it should be. There is an option to monitor VMs in your own data center in addition to the Azure-based VMs. An agent can be installed there, and the Azure Security Center can communicate with that agent to verify that those VMs also meet your requirements, have the necessary patches, and are secure. Using the Azure Monitor that we talked about in the management section, you can get a visual representation of your environment's security as well as the other information you're monitoring. As a result, A significant portion of the security center's function is to inform you of problems and offer advice. Do you have any ideas to make this more safe? Naturally, we want our solutions to be secure by default, but the Security Center can help you identify and mitigate risk if, during the development process, you unintentionally exposed yourself to it. Additionally, you can receive notifications when events occur in your environment that raise a red flag for your system's security. In addition, there are some cloud-based security services with a familiar interface. Azure Sentinel, for instance. All of your resources will be monitored by CM, but the cloud, AI, and machine learning will be used, as well as the virtually limitless computing power available to you. On top of that, we have the well-known Defender brand for Azure Defender, which protects your virtual machines and platform as a service instances from additional threats, all while taking advantage of your ability to run your business in the clouds. The identity that we talked about earlier can be utilized across your Azure resources by using role-based access control. You can better secure your Azure subscription by identifying not only specific people and users, but also system identities or managed identities, which are accounts used to host your services and which can be assigned role-based access to various resources within Azure. As an example, let's look at how we might put some of this identity and security to good use. There are a number of ways to do this. Think about that web application, and perhaps you'll call an API. However, you must include a specific key in the header in order to accomplish this. As a result, Key Vault is where we are looking for the key. It is likely that we will use Key Vault in conjunction with our Resource Manager and other deployment tools as a means of storing data. Our web application will retrieve this key and use it to access the API when it is running in the background. In order to gain access to the key, you may be wondering, yeah, but don't I need some sort of credentials or secret? And that managed identity comes into play in this case. If you use a managed identity, you can grant that identity permission to read keys from the Key Vault. As a result, we will be able to store the keys in a secure location and restrict access to them at runtime. How will you authenticate your users for your web application? This is another example. In addition to the app service you have deployed to Azure, Azure Active Directory is included as part of your subscription. However, you want to authenticate your company's employees. That way, your Azure Active Directory and internal Active Directory are in sync, and the users in both are represented. Users will then be able to access your web application using their corporate credentials. Users who have already logged in with the same credentials on another computer can use the single sign-on feature to avoid having to enter their credentials again. If you're going to build your website with external partners or users in mind and want to manage them and provide them with a sign-up, login, and sign-out process, an Azure B2C directory might be a better option. When they create their accounts, you have the opportunity to collect personal information about them. Then your web application will be accessible to those third parties as well. It's up to you whether to combine them or choose one or the other based on your needs. Security and identity have been the focus of our investigation thus far. As a reminder, we have the same powerful Active Directory system you have been using for years in your enterprise, but now built out at cloud scale with all of the reliability and features that you need for cloud applications. Advanced solutions are available to protect your data and identity information as well as the keys and secret codes you need for your secure applications. We also have safeguards in place for applications. When it comes to your directory, we have got things in place to make sure that all of your applications are registered and configured correctly, but some other applications are unable to do so.